So in this video, we're going to do an actual example of applying the triangle rule in order to see how vectors add from a geometrical perspective. So we're given information about two vectors. We're told vector A has a magnitude of 2 and an angle of 135 degrees, and vector B has a magnitude of 1 and an angle of 90 degrees. And what we're asked to do is to actually draw the sum of those two vectors, which is called the resultant vector, using the triangle rule. So I've copied this information over into my DocCam. Remember, this is a polar form description of these two vectors in the sense that we're given their magnitude. We write magnitude as the variable name with two vertical lines around it, kind of like the absolute value symbol. And we write angle as the angle symbol followed by the name of the vector. So if I were to sketch these two vectors just by themselves, kind of in free space, I'm going to put a coordinate system just since remember that this angle is defined with a particular convention from the positive x-axis. So when I go to sketch vector A, it has a magnitude of 2 and an angle of 135 degrees. So here's the way that I'm going to sketch that. I'm going to start at the origin and I'm going to go out 2 units. So this is 1 unit, call that 2 units. And just imagine that my pen was only 2 units long. Since this is a positive quantity, a positive angle, the way that I'm going to rotate my pen is in the counterclockwise direction. So I'm going to rotate this pen 135 degrees in the counterclockwise direction. Notice that the first 90 degrees takes me up to the positive y-axis. If there's 135 total that I need to rotate, don't forget that you still have an additional 45 degrees to rotate. So 45 degrees is half of a quadrant. So it's going to take me perfectly at the midway point of these two, the two axes in the second quadrant. And what I'm going to do is kind of, and if it helps, you can kind of sketch in a line at that angle, just kind of sketch it in lightly. So what we've just shown there is that this is 135 degrees. And what I want to do is along this line, go out 2 units. So imagine that you had that original length that you translated. So probably it's going to be perfectly right there. I'm just joking. Clearly, this is likely not the same scale that I kept originally. And I'm not trying to draw that vector as additionally like wide. It was just, I always have to write it at an angle when I'm on my DocCam. So kind of a little bit tough. But there is the vector A. And the second vector that I want to draw is a vector that has magnitude of 1 and is at a 90-degree angle. So 90-degree angles are easy, right? Because when you start with 1 unit along the positive x-axis and then you rotate 90 degrees, you're just going to go up along the vertical or the y-axis. So vector B is just going to look like this. And if I took and I physically measured the distance of B, it should be half the actual distance of A to scale. But what I want to do is actually show how these add according to the triangle rule. So if I'm trying to add A to B, what I want to do is take B and actually move its tail to the tip of A. So rather than actually show the X and Y coordinate system anymore, because remember, I just used those in order to be able to easily see and define my angles and attempt to scale my magnitudes to one another. But I know now that A is just going to be a vector of 2 length, and it's going to be at 135 degrees. And you can show it in there if you want. Because when you take, for those of you that are going the mechanical engineering route, when you take your statics class, when you first work with vector addition at the beginning of the course, you're going to have to do a lot of geometrical interpretations of vector addition, even though it's not very practical. So there is my vector A. And remember, that is its tail and that is its tip. So what I want to do now is take B, and I will actually write it out here. So I'm going to take the tail of B, because that's the vector that I'm adding to A, and move or translate to the tip of A. So just redraw that here. So it is of unit length, meaning that its magnitude is 1, and it's at a 90-degree angle. So literally all I did is I moved this B over here to A. I moved the tail of B over to the tip of A. And then that is the next thing that I want to do is basically draw the sum. And remember, that's also called the resultant vector to close the triangle. So we're talking about going from the tail of A to the tip of this translated B. So just draw kind of a line to close that out. And then remember that sum vector will go from the original or tail of A all the way to the translated tip of B. And this is the vector A plus B. So on the homework or on an exam, if I ask you to draw the sum of two vectors using the triangle rule, that's what you want to do. Take the second vector and put its tail on the tip of the first vector, and then just close the triangle from the tail of the first vector to the tip of the translated second vector. And that is actually your sum or your result vector. And hopefully that's not confusing, because remember, that is an example that we kind of worked up here in that the example of walking 10 feet north and 5 feet east before we even talked about any of the triangle rule or anything. So in the next video, we'll do an example of vector decomposition, and we'll get to use a lot of those concepts from trigonometry that we kind of just rushed through at the beginning of the lecture. This will really be your example to go step by step and see how that works.